Okay, so we've done 10.1, 10.2. Let's get our stationary point. So we should know stationary point. That is going to be your turning points. So you want to find turning points. You should also know turning points is where your derivative is equal to 0, where your gradient is 0. So how do you find derivative? That's the first thing we need to do over here. So I'm going to keep all of those. We still need that. Derivative is f prime. This function's name is f prime x. So let's just go and apply our rule here quickly. Let's see. The 3 is going to multiply with the 1, so it's going to be 3x squared. 3x squared. Our second term, minus 12 multiplies with the 2, so that's going to be minus 24x. And the last one was positive 36. So let's just double check that quickly. So yes, 1 multiplies with the 36. So there we have our derivative. Okay, great. But now you also know that at your stationary points, your derivative at your stationary points is equal to 0. So we're going to go replace this thing with our 0. So let's say 0 is equal to 3x squared minus our 24x plus our 36 over there. Great. There's a 3 that's a common factor, so everything's going to divide with 3. So I'm going to divide that with 3 also, so you remember that everything, all your terms are going to be divided by 3. So 0 is going to equal to x squared minus, that's going to be 8x plus 12. Okay, there's another trinomial for us. Okay, basic trinomial. Let's go with our 2 sets of brackets, x and x. Factors of 12, I'm going to put it over here, 1 and 12, 2 and 6, 3 and 4. Those are all. We need a 8, so we're going to use the 6 and the 2. We need a negative 8, so it has to be minus and minus. Okay, great. We still know how to factorize trinomials. And then we get our 2 solutions, right? So this one is going to be x minus 6 equals to 0. And x is going to equal to positive 6. We already knew this one, right? Because when we found our x-intercepts, we found 2 of our brackets being the same bracket. So you already knew that this point is going to be the turning point, right? Or one of your turning points at least. This one is x minus 2 equals 0. So that is just going to be x equals, this is a 2, x equals to positive 2 because you added 2 on both sides. Right, so we have the x value. So what have we found? We found the x values of our turning point. A turning point has an x and a y, so we still need the y value. So what's going to happen now? We're going to put these values that we found back into our original function. Okay, so we had x cubed minus, well, was it minus? Let's go double check there. What was our function? Was a minus 12x squared. Minus 12 x squared, and then we had a plus 36x. Right, so all of this, let's go put this into the calculator. Let the calculator do this work for us. And the calculator says 0. Okay, so you should have known that because that point is also your intercept, right? So this one is going to be 6 and 0. That was our x-intercept. Right, then we need the other one, so it's going to be f of 2. So it's going to be 2 cubed minus 2 times, or 12 rather, 12 times 2 squared plus 36 times 2. Right, again, this all of this nicely into our calculator. And that's 32. Okay, coordinate is 2 and 32. So we found our 2 stationary points, our turning points, this one and that one. Let's cut this video here. Let's see, what do they ask us next? Point of inflection. Well, let's do it. Let's go ahead and find the point of inflection as well, because that's obviously not going to be too long. So point of inflection, we understand that that is your second derivative equated to 0. Okay, so we need f double prime of x is equal to, so let's go to f prime, and then we're going to apply our derivative there again. So f prime was over here, so we're going to apply our rule to this once again. So the 2 is going to multiply with the 3, 6x and minus 24. Okay, 6x minus 24. Right? We applied the rule of derivatives on our first derivative. Okay, and at our point of inflection, we know that f double prime is equal to 0. So we are going to replace this thing with our 0. Okay, so let's do that. So we'll say that 0 is equal to the 6x minus your 24. Okay, so we want to get x on its own. So we'll say positive 24 is equal to 6 divided by x. Well, 6x rather, divide both sides with your 6. So x is going to equal to 4. Okay, so now you have your x value of your point of inflection. You need your y value. So this 4, where's this 4 going to go? Back into our original again. And our original was x cubed minus 12x. Well, let's put the value of x, which is 4 squared plus 36x. My calculator does this work for us. 4 is the x value. Calculator says 16. So our point of inflection is at 4 and 16. Great, let's cut it there. I think in the next video, we'll draw the graph.